Hello dear students, how are you? I hope that you are fine. Today we will be solving another sample problem related to Kirchhoff's rules. The circuit is sketched here for you. As you can see, we have two parallel connections in the circuit and they are connected to a 12-volt battery. Kirchhoff rules are the two rules that we usually use, which are the junction rule and the loop rule. Let us start by first drawing the battery arrow. As we learned together, the battery arrow must be from the negative side, which is the short side, to the positive side. Then we will start assuming one direction of the current. So I'll say here I have current I1. Also you can name it I node or I0. This I1 will be splitting here into two parts. So I1 will be entering the junction here and splitting to I2 and I3. They will gather again here, making once again I1. I1 will split here to I4 and I5. I4 and I5 will gather back again, making I1. And this is how I named all the currents in the circuit, and I need to find from I1 up to I5 what is the value. To do this, we need to start. Let's start by the junction rule. We say that here at this junction, I1 is equal to I2 plus I3. Also, I1 is equal to I4 plus I5. Now we will start applying the loop rule. As we said, we need to assume some loop direction. I can take the outer loop here, the larger loop, as loop A, and two small inner loops here and there. So I have loop A here, the big circuit, loop B, and loop C. So I can see that I have here three loops. For loop A, it's hard for me to see it clearly unless I simplify my circuit a little bit. So here with the green, I will sketch the simplified circuit. If we calculate 200 and 300 in parallel, and I think all of you are experts now, you will get 120 ohm. You can pause the video and check that 200 and 300 in parallel result in 120 ohms as equivalent resistance. 450 and 250 in parallel will result in 160.7 ohms. So this is my simplified circuit. This will help me see clearly what's happening in loop A. Again, I need to make sure all the time I sketch this arrow because it will help me determine the sign of the potential in the battery. Now the loop rule says, start applying it for loop A, delta V across any loop is equal to 0. Now focus here on loop A. On loop A, I have three elements that I will be passing. The battery, which gives 12 volts as given, the first resistor here 120 and another resistor of 160. The current that is passing is just I1 here, the total current. So for the battery arrow, if I am with the loop, it will be positive voltage. If I am against, it is negative. As you can see here, I am with the loop, so 12. Now, for the current in the resistor in R, if I am with the loop, it will be negative. This means that there is voltage drop through this resistor, and the same goes here. So here I1 is with the direction of the loop, so minus I1 120. This is the voltage IR across this resistance, minus I1 160.7 equals 0. So for the battery, if you are with the loop, it will be positive voltage. For the current, if you are with the loop, you will have negative voltage. And the voltage is the current times the resistance. This is why we are multiplying I1 times 120 and I1 times 160.7. This is a simple equation with one variable. You can find that I1 is equal to 0.043 amps. And this is the first current that is required from me to calculate, and I am done with it. Okay, so now let us go ahead and study loop B. Loop B is the loop here in this part, and loop B will be through two elements, the 200 ohm and the 300 ohm. Again, the current here is actually against the loop, so we will have positive voltage here, positive I2 times 200, since the current is opposite to the loop direction. Again, they are assumed loops, so if you assume the loop in the opposite direction, the signs will be flipped, and there is no problem with that. Kirchhoff rule has the self-correcting nature. And here for I3, if you follow it, it is with the loop, so negative I3 times 300 ohm. This will give me 0. Now, to solve this equation, I need to get some help from the formula that I found here. Let me name it 1. So, from equation 1, I can know that I2 plus I3 is equal to I1, which is this one. 0.043 is equal to I2 plus I3. So this is just equation 1 from the junction rule. I can arrange it in a way that I write it for I2. I2 is 0.043 minus I3. Let me name this equation 2. Actually, let me name this one 2 and this equation 3. So I will be substituting now this equation here. Substitute 3 in 2. I will get 0.043 minus I3. This is the value of I2 multiplied by 200 minus 300 I3 equals 0. Now you're left with some math steps. Don't forget here that you will be distributing this value. So you will have 200 or negative, don't forget the minus sign here, minus 200 I3 minus 0.043 times 200, it gives 8.6. Actually it's plus 8.6 minus 300 I3 equals 0. If you solve this for I3, you must get 0.0172 amps, and this is I3. Let me also box I1. This is a great chance, girls, to test your math skills and to make some practice in solving systems of equations. Now we found I3. Notice that so far I1 and I3 are positive, so the assumed direction is correct. Now we can also go back to equation 1 and substitute all the values that we have to find I2. I1 equals I2 plus I3. This is equation 1. I know now I1, it's 0.043 I2 is still unknown, minus I3 is calculated, 172, so you can find I2. It will be, if you try it, you will get 0.0256 amps. So I found so far I1, I2, and I3. I1 will split here into two new combination of values, I4 and I5, and again I1 is equal to I4 and I5. So I need to repeat the same steps for loop C in order I find I4 and I5. Okay, so as we said, from the junction rule, we know that I1 is equal to I4 plus I5, and I can apply now loop C. Loop C. For I4, I am against the loop, so it will be positive. Positive I4 times 450. For I5, I am with the loop, so this gives me a voltage drop or a negative voltage. Negative I5 times 250 is equal to 0. So here, again, let me name this equation. I think I can name it now. Let me say equation star. And this is equation double star, just for change. So here, 0.043, this is the value for I1, is equal to I4 plus I5. I'll be substituting this, so I4 will be 0.043 minus I5. I will substitute this in double star in this equation. So 0.043 minus I5, it's just long math, but it's not hard, multiplied by 450. So this is the value of I4. I replaced I4 here by the value that I got from the equation star, minus I5 multiplied by 250 is equal to 0. So solving this by again distributing and adding the like terms, I5 will be equal to 0.0276 amps. Now you need to take this value and substitute I5 in the equation that I called star, so you will get the last current I4, which will be 0.0154 amps. I tried to make the video simple without going into the details of the mathematical steps. They are very simple. They are solving one step or one equation with one variable. So please make sure that you know how to reach the final answers, and if you are facing any problem, we can discuss in class. Thank you very much. I hope you enjoyed the problem.